student, presently we are studying about the modem part. Modem is a very important device that is used in the telemetry system to make a connection and send the data through the channel from transmitter side to the receiver. As modem stand for the modulation and demodulation, you are going to discuss here some important things that which kind of modulation technique you are going to be used in the modem application. In the previous lecture, we understand about what is modulation, why it is required, then the types of modulation. When we talk about the types of modulation, it came into picture that PM means phase modulation, frequency shift keying, phase shift keying, QPSK and QAM. These are the most used modulation techniques by the modem systems. In modem, actually I told you that sometimes we required various modulation techniques advantages in a single modulation techniques. That is why this QAM technique came into the picture. In the previous one, as I told you about the QPSK technique, because it is very much required in the QAM, because QAM stand for the quadrature amplitude modulation, means at the same time it is going to change amplitude as well as the quadrature in the phase information. So, to understand this quadrature, we gone through this QPSK, and you understand one point very clearly, that in QPSK we use the unit magnitude amplitude 1 with a difference of quadrature means 45 degree, then 135 degree, so and 90 degree, so off. Here is the in this part there is a difference between two carrier, that is 90 degree. So, in that previous part I denoted 00, 10, 101 and 11, these 4 bit symbols, and divided the complete available bit stream into two parts of even bit stream and odd bit stream, and then the even bit stream and odd bit stream are modulated by using in phase and quadrature carrier to modulate to perform the quadrature phase shift keying modulation. So, in this QAM part, what we are going to do, we are using this quadrature in phase and quadrature line both with the change in the amplitude. So, it is a hybrid technique. So, you can understand in quadrature amplitude modulation, it is a form of modulation which is widely used for modulating data signal onto a carrier used for radio communication, and in the telemetry you required that the radio communication maximum. It is widely used because it offer advantages over other form of data modulation such as PSK, and although many form of data modulation operates along each other, means it is improving the advantages of PSK and getting some more advantage and making a more precise system. Similarly, in the QAM is a signal in which two carrier shifted in phase by 90 degree are modulated, and the resultant output consists of both amplitude and phase variation. Because of that fact, the both amplitude and phase variation are present, and it also be considered as a mixture of amplitude and phase. This is about the basic introduction of QAM with reference to the waveform and the block diagram. Here you can see that you are using a 2 raised to 1 converter in which you are getting a bit stream and dividing it into 2 bit stream of even bit and odd bit. Now, here it is a oscillator, that is a local oscillator that used for the carrier generation, and that carrier oscillator is giving the in phase data and quadrature carrier by changing this 90-degree phase shifter. So, what you are doing actually, you are getting these 2 raised to 1 converter even and odd bit stream, you are going to perform the modulation here and getting 2 lines, 2 in phase and quadrature line, and by summing you are getting this QAM signal. It is somehow related to QPSK. So, you can see here that here is the bit stream, that bit stream is divided into AK and BK, that bit stream are individually modulated by these in phase and quadrature carrier, and as per the resultant you are getting these two A and B different channels, and then by combining both of this you are getting this scheme. So, in the QAM you basically understand this point, somehow its working is quite similar to QPSK. So, when we are talking about this, you have to understand about its constellation diagram. So, constellation diagram, as I told you in the previous one, that was for the QPSK, you see that we have this arrangement 1 1 1 0 0 0 0 1. These are the arrangement as per the constellation diagram. Similarly, for the QAM, when used for digital transmission for radio communication application, is able to carry higher data rates than ordinary amplitude modulated scheme and phase modulation scheme, and as with the phase shift keying, the number of points on the constellation is indicated in the modulation format, description as 16 QAM use 16 point constellation. Now, understand this point. In the QPSK, we are going to combine 2 forms, 2 bits means 2 to the power 4, 4 symbols, means if you are getting 2 bits, there are 4 possible symbols, that are 0 0 0 1 1 0 1 1. But when we are talking about the QAM, it can change the number of symbols as per the requirement. So, it is widely used in a complete spectrum of the utilization. So, you can understand here it may be a 16 QAM, and 16 QAM how it is coming, as you are using 3, then it is a 8 QAM, you are using 4, it will become 16 QAM, means now you have a combination of 4 bits and symbol vary between 0 0 0 to 1 1 1 1. So, when using QAM, constellation points are normally arranged in square grid with equal vertical and horizontal spacing, and as a result the most common form of QAM use a constellation with a number of points equal to the power of 2, means 2, 4, 8, 16 and so on. So, as in this part QPSK you see this constellation diagram, in the QAM you have the another constellation diagram which we discussed earlier later, that by using higher order modulation format, more points on the constellation can be added. Also, it is possible to transmit more bits per symbol, means you can increase the bits in per symbol. Also, the points are closer together and they are therefore more susceptible to noise and data errors, because you are making the symbols by combining more and more bits. So, there is a chance of noise and data errors. Also, to to the provide the how a QAM operates, the next sequence in associated amplitude and phase rates we are going to consider. So, you can see here in the constellation diagram, this is a 4 QAM constellation diagram, this is a 16 QAM constellation diagram. You can see here the constellation diagram shows the different position for the states within different form of QAM, where quadrature amplitude modulation, and as the order of the modulation increase, so does the number of point on the QAM constellation diagram is also decrease. So, this is the variety of modulation 4 QAM and 16 QAM. Then the most important and most basically used 16 QAM for a modem, and the basic definitions with the basic criteria and key characteristics are here, that for 16 QAM 16 state quadrature amplitude modulation means there are 16 states. For 16 states we use 4 I values and 4 Q values, means 4 in phase carrier, 4 quadrature carrier, means 4 bits per symbol. Then 16 states means to the power 4 16. Theoretically bandwidth efficiency is 4 bits per second per hertz. So, data is split into 2 channel, the same as QPSK I and Q in phase and quadrature. As the with QPSK each channel can take on 2 phases, however 16 QAM also accommodate 2 intermediate amplitude states, means in the previous 4 QAM you are using only 2 phases changes, but in QAM you can also use 2 intermediate amplitude changes. So, 2 bits are routed to each channel simultaneously, as I told you earlier, and the 2 bits to each channel are added and then applied to the respective channel modulator. So, as per that the 16 QAM constellation diagram you can understand by here. In this part, this is the 45 degree, 135 degree, 225 and 315, and these combination of 4 are there. You can here see that for individual symbol, because when we are talking about to the power 4 means 16, 16 means 16 combination are from 00002 to following 0001 to 1111. So, here you can see that for individual symbol transmitted you have a different carrier phase and different carrier amplitude. Here you can see that you have 4 amplitude levels that are 0.33, 0.75 and 1, and somehow there is no change in the amplitude, that is the 4th one. So, these are the carrier amplitude changes, and with the changes in the carrier phases, for each you have a different carrier. So, you can here see that for this constellation diagram you all have these information. Then the QAM application. So, when we are talking about the QAM application, that QAM is widely used in the modem and also in many radio communication and the data delivery application. However, some specific variant of QAM are used for the specific specification and the standards. For domestic broadcast application, 64 QAM and 256 QAM are often used in digital cable television and cable modem application. In UK, that is 16 QAM and 64 QAM are currently used for digital terrestrial television using DVB, digital video broadcasting television, and in US 64 QAM and 256 QAM are the mandated modulation scheme for digital cable as standardized by the SCTE in the standard NCSTE 07-2000. Also, QAM in addition to this variant of QAM are also used for many wireless as well as cellular technology application. But beside these, some are the advantages and disadvantages also that we already discussed, but we are pointing out here that QAM has a advantages of appear to increase the efficiency of the transmission for radio, and also the communication system by utilizing both amplitude and phase variation, combining a hybrid technology. There are some disadvantages also, such as more susceptible to noise between the state closer together, so that a lower level of noise is needed to move the signal to different decision points. Similarly, receiver for use with phase and frequency modulation are both able to use limiting amplifier that are able to remove any amplitude noise and thereby improve the noise reliance. That is not the case with QAM. QAM may that is not possible. Then the second limitation is also associated with the amplitude component of the signal. When a phase or frequency modulation signal is amplified in a radio transmitter, there is no need to use the linear amplifiers, and whereas when using QAM that contains an amplitude component, linearity must be maintained. Unfortunately, linear amplifier are less efficient and consume more power, that is why this make them less attractive for the mobile application. So, these are some QAM disadvantages. So, after talking about these modulation scheme used for the system, you understand that in the modem you have combination of modulation schemes such as QAM, you have individual the QPSK, FSK or PM phase modulation. So, these are the basic modulation scheme used by the modem circuits. Now, we are going towards the protocol. Basically, when we are talking about the modem system, it is going to transfer the data in the digital format. When the data is transferred into the digital one, some protocol has to be followed. That protocol is going to give us the frame structure or the structure of the individual packet that is going to be transferred digitally. That is why in modem basically they are using X-MODEM protocol and Synchronous Bisync protocol. In X-MODEM protocol, it is widely used in data transmission between PCs. It use asynchronous method and ASIC codes, ASCII code, and each character have start and stop bits, because it is a asynchronous method. And I told you in the class at a part of classification of modem, as per the synchronization we are using asynchronous modem, they use start and stop bits rather than clock signals. In synchronous protocol, it is more complex than X. It use various control characters, look at the beginning and the end of the data block, and it is widely used in the computer communication. Means for the individual transmission between PCs, X-MODEM, for the synchronous, for the computer combined communication. Then X-MODEM protocol procedure. In X-MODEM protocol procedure, you can easily understand the point that it is having basically receiving computer send negative acknowledgement, means the computer which is receiving the data first of all send the receiving negative acknowledgement to the system, then transmitting computer recognize any negative acknowledgement and begin to send data block with the start of head SOH. Start of head is actually showing the starting of the frame. Then a 128 byte block transmitted, and in the end of that block there is a checksum byte will be sent by the transmitter to check the check that any error is introduced in the system or not. That is about the checksum byte. Then the receiver compute the checksum for the errorless reception, because as per the calculation with this checksum, it the receiver can decide that the reception is errorless or there is some error present. Then if okay, then receiver send a acknowledgement, now acknowledgement, and if error found, receiver send negative acknowledgement. If there is negative acknowledgement, again transmission will be done, and if there is a okay means acknowledgement, then the next transmission will be initiated. So, in the end of the transmission there is a EOT sent by the transmission, means the complete transmission is over, then again the receiving computer send the NAK, means this complete process is starting with the NAK from receiver to transmitter, then the process will be done. After that the checksum correction and if find there is error or not. If the complete transmission is okay, then receiver send transmitter the acknowledgement, and if acknowledgement is okay, then the end of transmission sent by the transmitter to receiver, that is EOT, end of transmission. Then again this process will start. Otherwise अगर ये नहीं होता है, means acknowledgement is not going, then again this process is here. Means this protocol, X-MODEM protocol, is a asynchronous modem protocol in which the complete system is going to work with the reception and transmission of the signals coming from transmitter and receiver in the form of negative acknowledgement, end of transmission, starting of head, these all are the points. So, in the Bisync protocol, this is the structure. We have sync, starting of head, header, data, end of term BCC, that is binary check codes. So, you can understand here it start with the to sync for signaling the beginning. Actually in this part there is not any type of acknowledgement is there, they are directly working on the clock, and in this you can see that there is a frame, that frame is starting with the to sync blocks, then start of head to identify the message sent, the block number, specific routing destination, priority code, means start of head the complete address of the information, address of the receiver destination, and that is maybe a some specific route that is going to be follow or something else. Then the start of the text followed by the data block, that data block having the all data and start of head showing that now the data transmission is starting. Then the end of the block, end of the black or end of the text ETX, that shows the end of the data. After that EOT means transmission is over, and in the last there is a binary check code for 1 or 2 bytes error detection codes. Means you can easily differentiate between synchronous and asynchronous, that in the previous one X-MODEM protocol what is going on, transmission and receiving is governed by the communication between transmitter and receiver. What is happening here, receiver is telling the transmitter to send the data, then after receiving transmitter again getting the data from the receiver, that transmission is over. Similarly, this communication is going on throughout the transmission. But when we are talking about the synchronous protocol, in this protocol a frame is designed in such a way that is synchronized with the clock, that the frame is transmitted from transmitter side to receiver, and after receiving the data, that frame, the receiver will act as per the frame structure. It is easily identifying the starting of the head and ending of the text and all that, ending of the transmission, and also applying here the BCC binary check codes to identify that there is any error or not. So, basically this is all about the modulation part. So, in this part basically in this unit we understand about the various things that are modem block diagram, its modulation technique and its modem protocol. So, in the exam the questions are mainly coming from this QAM and this modem protocol. So, always remember these 2 points when we are talking about the modem part. So, in the next lecture we are going to start with the transmitter and receiver part. Till then, thank you.